Hi everyone. Today we're going to study Chebyshev's theorem. What is Chebyshev's theorem? Chebyshev's theorem estimates the minimum proportion of observations that fall within a specified number of standard deviations from the mean. If you have a mean and standard deviation, you might need to know the proportion of values that lie within, say, plus and minus 2 standard deviations of the mean. Chebyshev's theorem helps you determine where most of your data fall within a distribution of values. There are two forms of the equation. One equation determines how close to the mean the data lie, and the other equation calculates how far away from the mean they fall. The first formula is 1 over k squared. This is the formula for the maximum proportion of observations that are more than k standard deviations from the mean. The other formula, 1 minus 1 over k squared. This is the minimum proportion of observations that are within k standard deviations of the mean, where k equals the number of standard deviations in which you are interested. Take note here that k must be greater than 1. Using the formula given a while ago, we're going to construct a Chebyshev's theorem table. Here we have 3 columns. The first column for the standard deviations. We assign values here, square root of 2, 1.5, 2, 3, 4. The second column, we're going to use this formula to represent the minimum percent of observations within. The third column is for this formula 1 over k squared. This represents the maximum percentage of data outside the standard deviations. So, when standard deviation is square root of 2, the maximum percent outside is 0.5, while the minimum percent within is also 0.5. When standard deviation is 1.5, the maximum percent outside is 0.44, while the minimum percent within is 0.56. When standard deviation is 2, the maximum percent outside is 0.25, while the minimum percent within is 75%, or the 0.75. When standard deviation is 3, the maximum percent outside is 0.11. For the minimum percent within, that is 0.89 or 89%. When standard deviation is 4, the maximum percent outside is 0.06, while the minimum percent within is 0.94. For example, if you are interested in a range of 3 standard deviations around the mean, Chebyshev's theorem states that at least 89% of the observations fall inside that range, and no more than 11% fall outside that range. Let us see this example. A data set has a mean of 100 and standard deviation of 5. Letter A. What is the range of values within two standard deviations? Letter B. How many percent of the data falls within two standard deviations? Let's start with problem A. We're going to write this formula, mean plus or minus k times standard deviation. The k here is the number of standard deviations that we are interested in. Substituting the values to answer letter A, we have now the mean as 100 plus or minus the k is 2 as given in problem A, and our standard deviation is 5. So 2 times 5 is 10. So this is now equal to 100 plus or minus 10. So let us split the plus and minus. Using the plus, we will get the upper limit. So that is 100 plus 10 equals 110. For the minus, we will get now the lower limit. 100 minus 10 equals 90. So the range of values is 90 up to 110. This is the answer for letter A. Let us now solve for letter B. How many percent of the data falls within two standard deviations? We can go back to our table a while ago. The standard deviation of 2 is here, so our answer is the 0.75 or 75%. So we say here, Chebyshev's theorem tells that at least 75% of the values fall between 90 to 110. This is now the final answer. I hope you learned something from this video. See you again next time.